Maybe if the show was 30 minutes.
All right. So everything that we've taken the derivative of so far has been in a y equals format. So now we need a method in case it's not in the form y equals. Okay? So what we're going to use is what's called implicit differentiation. Okay? And here's the rules. You're going to differentiate both sides of the equation with respect to x, but you're going to treat y as a differentiable function of x. What that means is if you've got 4y in the equation and you want to take the derivative of that, you think of it as x, so what would be the derivative of that? 4. But we're going to tack on a dy dx because we're really doing everything with respect to x. So in these equations, if it's x, you'll just take the derivative as usual. If it's anything with y, you've got to tack on a dy dx. So if I had 3y squared plus 2y, what would be the derivative of that? 6y dy dx plus 2 dy dx. And ultimately, we will be solving for dy dx because that's the derivative. Because we are taking the derivative of y with respect to x. We're treating it differently because we don't have the equation to start with in y equals form. And it's difficult to get it into that form, so we use this process to do that. Okay? So we'll do that, and then we'll collect all the like terms, and we'll get dy dx all by itself, and we will have solved for the derivative. Okay? All right. That's just a picture that we don't really need. It was kind of a scary picture. Okay. All right. Need a little bit more room. See if I can do that without covering up things. Okay. It says, use implicit differentiation to find dy dx. And so we've got this whole thing here. I'm going to make it bigger. Okay? So, what do you recognize about this and about that?
They got y.
They've got y in them, but they're products. They're products. Those are both products. Okay?
You only take the derivative of y when you need the derivative.
Right, right.
You only differentiate.
Yes. So that's why the roadmap becomes important in my mind. Okay, so if we're going to write this, this is a product. So we would have, not in red, 3x squared times d dx of y plus y times the derivative of 3x squared.
Wouldn't it be... Oh, wait, never mind. I see what you mean.
Did I
I was thinking
miss
about
something?
y squared on the other one.
Oh, okay. Plus 4x times derivative of y squared plus y squared times the derivative of 4x equals, what's the derivative of negative 4? 0. Okay, you always like to have those constants over there because they go to 0. So let's look at where we're taking derivatives. Here, 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 and here. Okay? Everybody good with that? So we've got 3x squared times what? Okay?
Yeah.
That's the derivative of a constant is 0. Okay? Question, Mitchell?
Y into dy dx.
Yeah, if you were taking the derivative of x, it would be 1, right? Well, this is 1, but we always have to tack on the dy dx. Okay? All right, plus, now we're not taking the derivative, and Jeremy, this is what you were saying. We're not taking the derivative of y. We've got y times, what's the derivative of 3x squared? 6x. Plus 4x times, what's the derivative of y squared? dy dx plus y squared times 4 equals 0. Okay? So I've got 3x squared dy dx plus 6xy plus 8xy dy dx plus 4y squared. Catch me if I miss something. Then what you want to do is collect the terms that have dy dx and put them on the left and get everything else on the right. I mean, it doesn't have to be that way. You could change sides. But I'm going to leave these two guys over here. 3x squared dy dx plus 8xy dy dx equals negative 6xy minus 4y squared. Does that make sense so far? And we're solving. Remember, what we're solving for is the derivative, which is dy dx. So let's factor dy dx out. And we are left inside with 3x squared plus 8xy equals this thing. And if we're solving for this, what are we going to divide by? This whole thing. Okay? So dy dx is negative 6xy minus 4y squared over 3x squared plus 8xy.
Why did you move that? Sorry,
That's okay.
why did you move the...
These guys
Yes.
over here, we're trying to isolate dy dx. So we want to leave anything that's attached over here and all the other guys that have no...
Without
Yeah.
dy.
It's like solving for x.
Yeah, but this is the guy that we're solving for, dy dx. That's what we're solving for. So ultimately, we have to isolate him. Okay? Is that coming back, you guys that did it in high school? painfully coming back. All right, everybody good? All right. It's really just algebra. Okay. All right, so this one, here's the equation. So I'm going to write it over here. X to the fourth plus y to the fourth equals 20xy. Okay. What do we get on the left side? There's no products over there. So what would be the derivatives over here?
X to the third plus 4y to the third dy dx.
Okay. So that's easy enough. Over here we do have a product. So we've got 20x times what? Dy dx plus y times 20. Okay. Is that good? All right. So what do I need to do now? Can I get this guy over here and that guy over there? So I'm going to have 4y cubed dy dx minus 20x dy dx equals 20y minus 4x cubed. Is that good? And then factor out dy dx. Did I? Oh, it'll work. It'll work. Sorry, I just looked at something.
Why is 5 times 20?
Why is this times 20?
Yeah, because you take the
Derivative.
20x.
See, it's 20x times the derivative of y, and then y times the derivative of 20x, which is 20.
Oh, it's a product.
It's a product.
I got you.
Yeah. Okay, so dy dx is 20y minus 4x cubed over 4y cubed minus 20x. What would you do to clean that up to get one of these answers? Take the 4 out. Okay. And then the 4's will cancel. And so you should get 5y minus x cubed over y cubed minus 5x. And I don't know, is that B or second one or whatever? Okay. You might have left it like that, and certainly if you left it like that on a test, it wouldn't be a killer. But if you're looking for a multiple choice, then you kind of know, oh, yeah, I do need to simplify that. Okay. Are we good? Ready to do one?
This is what I think mine.
All this stuff? All this junk? I got you. Are you still writing? Sorry. Let me know when you're done, Mitchell. You're good? Okay. All right. Okay, so here's our problem. 5xy plus y squared minus x.
It's supposed to be equal.
Is it equals? I think it's equals x plus y. Yeah, it is. I don't know why that doesn't print that right. That's weird. Okay, so you guys work that one. It's not quite as long. Do you have any products? Yeah, right there.
Wouldn't that segment be y times d dx? Oh, no, wait, I don't have an extra good one. I was specific.
Oh, okay. You will find yourself wanting to shortcut and not write everything, but be careful. You set yourself up sometimes. I'm smiling. That mean we got it? Okay. Here's There's only 11 questions. Okay, so you get really used to doing the product rule with this stuff, and so now we need to look at a quotient rule. Okay. Are we good? Absolutely. Where's the popcorn? We'd be really good. All right, there's that one. So we're going to get started over here. You've got that quotient on the right-hand side to do. Can I move up now, guys? Like there? Okay. What do you get on the left? Equals. Now, do we have any y's over here? Are we going to have any dy dx? No, we're just going to have regular derivatives with x. Are we getting here? Did we get that? What's the only other thing we could do? Could we have 15? Yeah. Is that good? The more you do, the easier they will be. And that's one of the reasons that you have 11 questions. That's not my typical number. I mean, usually 6, 8, maybe. But you need a little bit of practice on this. When you take the test on this stuff, I am going to ask you to write all your work out and turn that in the following class period. So even though you're doing it online, you're going to have to turn in that work. Okay?
So no, just guessing.
No? I think it'd be hard to guess that out of that. Maybe. I don't know.
If you can do it in your head.
Yeah, that's rare. That's rare. All right. Are we good on that one? You're still up here. Okay. There.
Actually, like the tree better because it does none of it goes together. So it's hard for it to go together. So
Yeah. Usually you just have these long answers. You're good? Okay. All right. This trig one's really pretty short. So you have x equals sine y. What's the derivative of x? Equals cosine y dy dx. And so if I'm solving for dy dx, what do I do? Divide. Could you go a little further?
secant 1.
Yeah. This is where just having trig comes in handy, because it's in your head, you know, oh, 1 over cosine, yeah, that's secant.
I'm so happy I did that and the algebra.
Okay, so we're good. I'm trying to think. Yeah, some of these we need to do. Okay, number 6. Did I skip one? No. Okay. All right. This is another one of those that it didn't print right, so that's an equals. Okay, so we've got x to the 5th plus sine y equals x cubed y to the 6th. Okay? So what do we get over here on the left? Okay, so that one's fine, right? We are. Equals. Now, we got a product. Okay. Have you got the answer, Keith? Because you're looking at the choices over there.
I took shortcuts, but I got it simplified to the step you're writing out right now.
Okay. Okay. Are we good there? So we got cosine y dy dx minus 6x cubed y to the 5th dy dx. Is that right? Equals 3x squared y to the 6th minus 5x to the 4th.
Well, that 2 is a 6.
Where? Is it?
1 to the 6.
Do you think that looks like a 2?
No, the
Is
one
it?
below it.
Oh, down here? Yeah. Okay. All right. So dy dx equals cosine y minus 6x cubed y to the 5th. I'm just doing that. Okay. See how many times I can write it. And can we see what the answers, this guy over this guy? So which choice is that? This one. Okay. All right. We're good? Okay. Some of us are with it and some of us are not.
See, when I got taught this, he just gave us the book and was like, here's the rules, go figure it out. That's why I took it again. So I wanted to make sure I had it.
Oh, my first teacher sucked.
Yeah.
He taught to us as if we've already gone through
That's how they
calculus.
talk about teachers.
And then we had, on our tests, like I made the highest grade one time. I made a...
Oh.
Okay, we'll finish that. Okay, so let's go ahead and go to this one. This one I wanted us to get to because it does have an e. So let's get that one done. E to the 9x equals sine x plus 2y. Okay. Scroll up. Yep, that's okay. That's all right. What is the derivative of e to the 9x? E to the 9x times 9. So we got 9e to the 9x. It's a really big x. Equals, what's the derivative of sine? Cosine of x plus 2y times what is the derivative of this thing? 1 plus 2 dy dx. Okay, you're good with that? All right, so we've got this with dy dx, and it's being multiplied by this thing. So let's divide this thing over here.
That's the chain over right there.
This, yes, yes. Oh, I was put on. It doesn't work well if you don't plug it in. So good, it warns me. I had it plugged in here. Okay, equals 1 plus 2 dy dx. And then what are we going to do? Subtract 1 and divide by 2? Okay. So I got this guy. Minus 1 all over 2 equals dy dx. Do we agree with that? Okay. The answer format that MathLab is actually looking for, and you know, if you left it like this for me, that'd probably be okay. But what they're looking for, whoops.
You could just invert that too.
I don't know if they would take it, you know, if you didn't write it as minus 1/2, but that's the way they have the format that they want, that I saw. So that's why I'm giving you that heads up on that one. Okay. Okay, we are almost done. We do need to do one with a second derivative, because when you have implicit differentiation and you do a second derivative, it's a little bit different process. Do you guys remember doing those? Not so much. Not something you keep in your head. Do what?
You're saying the second derivative is dy dx?
Yeah, when you do the first derivative and you've solved for dy dx, and then you take the second one, everywhere there's a dy dx, you substitute back in. So let's do this guy and see what we get. 3x squared plus 4y squared equals 1. So they're asking for the first derivative. So let's do that. First derivative. What do we get here? Equals 0. And so 8y dy dx equals negative 6x. I'm going to go ahead and say that's negative 3/4 over 3x over 4y, sorry. So here. So this is what dy dx is, and we need to remember that for when we get down to a certain part in the other part of the problem. But that part was okay, right?
That was easy.
That was good. We like that. All right. So now let's take the derivative of this guy. Okay? That's a quotient, right? So 4y times the derivative of negative 3x, not minus, okay? Is that right? So what do we get here?
Negative 12y
Negative 12y minus,
minus a negative.
we got negative 3x times 4 dy dx.
So
over 16y squared. Do we agree with that? Okay, and so in here, this is negative 12, so it's going to be a plus 12x dy dx. Okay, so negative 12y plus 12x dy dx over 16y squared. Everybody good with that? Okay. And then we are going to substitute in dy dx. What did we have for dy dx? Right here. So you're going to substitute that in. There's a lot of algebra that goes on now. Because this is multiple choice, isn't it? So we're looking for these kind of answers. Okay. So what do we get when we multiply these out? Do we get that? Okay, what do we need to be able to, I guess I could put this minus here. Well, do what, Lucas? You could. So you're saying simplify it right there. 12y minus, sorry. I was listening to you and trying to write over y over 16y squared. Don't we need a common denominator up here in order to combine these two? Nope. Did you say no?
No, you said that would help.
Oh, I thought you said nope. Okay. All right. So what am I going to get if the common denominator is y?
12y.
Okay. Y squared minus 9x squared over y squared all over 16y squared.
For y squared or y?
So good to have an eraser. Okay, is that good? I changed this negative 12y into negative 12y squared over y so that I have a common denominator and I can combine those. Okay? And so then what happens?
We flip the denominator and multiply.
Mm-hmm. So what do I ultimately get?
16y.
Mitchell, question?
What did you say you just did with the y?
With this y? Okay, I need to make this guy have y as a denominator, and so really maybe I should write that over here. Negative 12y over y. Is that the same thing as just negative 12y? Okay, so now I can combine these guys. I don't know why that's not working. And that's what happened. Okay, and so now I have negative 12y squared minus 9x squared over y times what?
16y squared.
So I have this over 16y cubed. Right? Is that one of my choices? I don't even remember.
Yeah, it would be.
You've got it up on your computer, don't you? Mm-hmm.
That wasn't the answer, like 2 seconds ago.
Which one is it? This one? Okay. And luckily, that is a multiple choice, so you kind of knew the area that you wanted to go to. But that's a lot of algebra. Lots of algebra. Okay. Oh my. Number 10 is a very, very long question. Let's not go there. What I would suggest about number 10, because it's just a lot of algebra. I'll show it to you, but I want us to do the very last question together because it's a little different than what we've been doing. And the number 10 is still just finding the second derivative, but it's complex. So it's a lot of algebra. But it's worked out online, so you can see it. But let's do the very last question before you fall asleep on me. Okay. Well, see, I took one out after I created it. There used to be 12, and now there's not. I'll show you the work for the other one. Okay, find the lines that are tangent and normal. What are normal lines? Yeah, they're perpendicular to the tangent, okay, which means their slopes are negative reciprocals. So if we find the slope of the tangent line, then we'll be able to find the slope of the normal line. We'll be able to write those equations of the lines. Okay, so we've got to do two things. Here's the equation that we start with. X squared y squared equals 36. If we're going to write the equation of a tangent line that hits this curve at this point, we've got the point, we need the slope. What is the slope? The derivative. So we got to find the derivative of this. So we're going to have to use implicit differentiation and do that. So I will let you do that. I'll work it up here as well.
This gets much easier the more you do it.
Absolutely.
First, it's just kind of overwhelming.
That should be a 2 in front of there. Okay, did we get that?
Wait, I don't think that one's supposed to be 2, where you put the 2.
Right here?
Yeah, because you're not.
2
2y.
2x
dy dx times ix squared. That's what you got.
Well, then where's your x squared? 'Cause the first time you don't multiply.
X squared times 2y dy dx. Isn't that the same
That's what
thing?
I
Oh, yeah.
She's already subtracted the others.
And then I moved that guy over there. And so then you do some canceling out, and I think you have negative y over x for the slope. Do we get that? Okay, that's the general rule for the slope for this thing, but we want to know the slope at this point. So at the point 2, negative 3, what's our slope?
3.
Yeah. Okay, so that's a really typical question for calculus where you're writing the equation of the tangent line at a certain point, blah, blah, blah. Okay, so we've got the slope and this point. So now the equation of the line is going to be y plus 3 equals 3 halves times x minus 2. That's using that point slope form that we've used before. Okay, so there's the tangent line. Everybody agree? Okay, and what's the only thing you've got to do to write the normal line? Yeah, the normal line, m is negative 2/3. So you write the same equation of the line, but instead of 3 halves, you're going to use the negative 2/3. No. Well, yeah, you're going to do this whole process again. Yes, the consonant will change. Okay. Does that make sense? So all we did was implicitly differentiate that equation, and we got what dy dx was. Then we evaluated dy dx at that point, got a value, got 3/2. Used 3/2 in the point to write the equation of the tangent line. To get the normal line, we did the reciprocal, negative reciprocal, and we got this. Okay? I'm going to show you the work for that one that we're not going to do. You're going to do it, but I'm not going to do it right now for you because once is probably enough. But I do want to show you. What was it, number 10? Okay. It is a second derivative, and it's this. Y squared equals 7e to the x squared plus 10x. Yeah. Okay, so... Oh, that was really mean of me, wasn't it? I'm going to go ahead and... Okay, that'll do that.
That looks like